Okay, hello, welcome to this video where we're going to catch up a little about what the difference is between a microcontroller and why you would want to select them against something like a mini computer. These items which I have in mind are generally commercially available, which are the Arduino brand, not affiliated, and the Raspberry Pi brand. Again, not affiliated, but they are essential to learning electronics and making it fun to learn, which is where this series is going. We've done a few other series which will be uploaded soon, so please like, subscribe, share along, keep watching, and hopefully you learn something. If you need any other information, we're also uploading a whole load of what a Notebook LM series. They're AI created sessions of basically deep dives into certain topics and things like that, so give them a look. I know they're a bit death by PowerPoint, but they're very, very useful information, and there's also podcasts coming up and things like that, so definitely subscribe, share along. But today I wanted to talk a little bit about the two different types of geekware, if you like, what we're going to essentially use in our day-to-day lives when we're doing things in a garage, like electronic hobbying, or you want to make a home assistant or something like that, you know, like Jarvis from Avengers or Iron Man. So that's all really powerful stuff. You can make tables go up and down and talk to you and everything like that. That uses a Raspberry Pi. Now that's brilliant because a Raspberry Pi is a microcomputer. Microcomputer runs software. Think of it, if you think of that as a small version of that, that's quite a weight. It's not a replacement for a big proper machine. Well, actually maybe this one because it's a bit old. The biggest takeaway is that a microcomputer will run software, it will run graphics interfaces, so you think display devices and things like that, like monitors, stuff like that, do your word processing, running Python scripts that will do artificial intelligence, computer vision, things like that. That's great. That's really, really good, and we all are fascinated about that stuff. Before you get to that, you have to understand a bit more about what's going on. So that takes you into the microcontroller world, which is what actually makes things work. If you think of a microcontroller as where have I got one? You have a remote control. This is a microcontroller effectively. It takes an input and it gives an output. For this one, it just basically lights a LED up in a certain sequence which is detected, and it communicates. It's a digital telephone, if you like, to a TV. This is a microcontroller. This controls how to put the data on a hard drive and how to recall it, how to organise it. But it's a constant script which is running time and time again every second. I mean, you can talk 100 times a second. People talk about refresh rates on monitors, 120 FPS, which is frames per second. Well, each time you run that, it has to run the script to display the image, because a video is a motion photo, if you like. This is taking 25 frames a second and then sticking them all to play out. So we'll get into cameras and things like that later. That's a bit deep at the moment. This is a memory chip. This is just a microchip. So there is a microprocessor on there to organise it, but that is just memory, and that is a chip. A microcontroller is made up of lots of chips and a bit of software that will run. Now, it's not software as you know, as we all know it. Sorry, like you think Microsoft Windows or Adobe, their image creation software. Sorry, I shouldn't really mention brands, but one brand you could mention is Blender. It's open source, and that is a very, very powerful 3D modeling suite and animation, of course, and we use that. But all of that runs on a computer. Now, the kind of software for a microcontroller is called code. Code makes up software, but this is effectively a microcontroller which will run as soon as it's plugged in. Its one purpose is to run that code. That's all it does. So it takes its inputs and outputs as defined in that code, and then does work according to that code which you have programmed. Now, Arduino provide their own integrated development environment, or IDE, which we will be using, and that's how you program the Arduino Uno. This one is a very basic one. This is an Arduino UNO R4. It's a very basic board. It's quite limited in its power, but for a microcontroller for learning, this is all you need, and you can buy these from certain distributors for like £3 or £4 now. You might need to buy them in bulk, but that's great, because a microcontroller will do one thing. If you make it do too many things, you might make it do 5 or 6 different things in the code to make it work properly. But you have to start planning your project. If you make it do too much, it will slow right down, or it might even crash. But that's alright, it's going to reboot anyway, because it only runs code all the time. That's all it does. It just runs that same set of instructions over and over and over and over. A microcomputer doesn't run that same set of instructions. It runs an operating system. Now, an operating system is like Windows, Linux, Ubuntu Linux, things like that, Mint. That is, if you're a Windows person, it's not the easiest thing in the world, but it's getting easier, and there's so much information out there to help you learn it. But that's what the Raspberry Pi runs. It runs Linux, or its own flavour, which is called Raspbian. The microcontroller, as I say, this is your electronics hobbyist absolute wet dream. This will make things like this a reality. So that microcontroller, if I delve into this project, that microcontroller, this one's actually a more modern one. This is an Arduino UNO R4 Wi-Fi edition, so you can connect to your phone. It has an LED output system, and it's got a 32-bit ESP32 add-on there. So it's really quite powerful for a microcontroller. But essentially, I've got a bunch of wires that connect up to it. It runs a script every so often, well, about 50 times a second, I think it is. That's how fast they are. It's a big script and it runs 50 times a second. If you remember, in computer terms, a second is an eternity. We have a buck converter, so this is our power board. We connect the 7 volt battery, well 7.4 volts I think it is, up to that, and that gives us a nice steady 5 volts output at a higher current level, which if you look at the other videos on Ohm's law, we'll cover it in this as well, because Ohm's law is so important. That will explain what happens there. We'll go into it later if you subscribe and everything like that. Share along. That's a motor controller. Again, it's got little integrated circuits. An integrated circuit is just, if you think about a whole bunch of fuses and capacitors and resistors, all miniaturized, smaller than you can see with the naked eye. That's what an integrated circuit is, and that's what we commonly call a chip. Each chip has a number, etc. We'll go into this later, not for this video. You'll be happy to know. So that then connects up to that block, which is what we call a hat. That, sorry, it's out of shot there. That connects up to there, goes in those pins here, those go in there, and then on that we have a camera, we have a compass module, we have a GPS module, sorry, this one's a GPS module, that's GPS receiver, and this is an SD card to write the data to that we want to collect. We might want to collect radiation samples, humidity. For me, I just wanted to create a rover that took photos. We might cover some more aspects in this series, but that is a complete series all on its own. With the Arduino, a couple of other little components here that we have. This is a basic motor driver. Does exactly the same as that one, but this is slightly better but lower power. Of course, on the wheels you have what we have called geared motors. So the motor goes in and it's got a little gearbox in this yellow section, and that spins the wheel a bit slower. Motors are about this size. We use that screwed terminal block, which pressed in is basically a fancy breadboard. And if you remember, I just mentioned about integrated circuits. Well, if you were to look at this, for instance, these would be 2 pins coming off of it to connect up, and then you have all these fuses, LEDs, things like that. Interesting, there are LEDs in some integrated circuits, and they are for high power. I've forgotten the proper name for them off the top of my head. But they basically, one LED lights another one, and I've gone slightly off topic, but it gives you a nice safe way to control like a relay, high power relay if you like. But you can put a low voltage in one side and you can get a high power out the other side from another power bus. So that is that. So that's a little introduction. You can also do little things like this, a little keypad, door entry system if you like, so no one can break into your hobby room, because you'll need a bit of privacy in this. So if we were to go back to, that is what a microcontroller does. It's very limited in what it does. I love them, right? And I especially love the Arduino series. I think they are fantastic. You can get really big high powered ones like the Leonardo massive ones, which are the boards like this. They have like 30 odd terminals on them and stuff like that. You can do so much, much more processing power, but they're still a microcontroller. If you want to talk, and this is where I wanted to clarify straight away for anyone watching this series, there is a common belief that, oh, you do electronics, you can make anything. There is expectations to be had. electronics like Arduino, they are great for real world control. When you talk about you want to move forward 10 inches, oh, you definitely want an Arduino. You want to move a robot arm, do all of this, you want an Arduino. 100%, it will do it, and it will do it fast, really fast. You can do all of that with a microcomputer like the Raspberry Pi, and this one's a Pi 5. That's going to do it using nearly no electric. Obviously you're going to use the power to move things, which is force times distance and all of that good stuff. And if you want to know more about that, look at the physics lectures. Bit of death by PowerPoint, but it'll get you there. So that will do it really, really cheaply with no overheads. If you think of it like having heavy management, right? That is just a one-man band. They're going out. They haven't got any management overheads. They've just got their van, their tools. Go do the job. That's it. You're just paying basically the labour of doing it, but in energy, right? So you can put a small battery like this, for instance, standard RC battery. It's actually about half the size of something like a Tamiya radio control car. But that will last you probably about a day of work. It'll run this for about an hour. This is very, compared to an Arduino, these don't use a lot of power, okay? Don't get me wrong. But compared to an Arduino, because of all of the processing, this has got a fan on it, it's got a heat sink, all of that is wasted energy. It's got USB, it's going to drive a display. If it doesn't drive a display, then you're going to remote into it, and you're going to start getting into things like SSH, which is remote operating of computers. Now, comes back to what I was saying about you need to know what you want to get out of this, right? If you want to build a robot, Arduino, 100% all day long, Arduino. If you want to build what we call an HMI, which is human machine interface, something like a SCADA unit that's going to run a machine. We have belt thickeners at work, but it might be a lathe, it might be an automated lane, or a conveyor belt system. That you're going to want something like a Raspberry Pi, or multiple Raspberry Pis, depending how big they are. But you will want to be going down the microcomputer route, because you're talking a control system. It's going to have a screen on it. It's going to be remote. It's going to be really, really intelligent. It's going to do a lot of things that's not going to be able to do, quite frankly. You just have to set your expectations. Again, it's like, do you send a labourer out to go and repair an aeroplane? You can't just give someone a hammer and expect them to do a complicated job. Right? Not saying a labourer can't do it. That's not what I'm saying. It's just you have to invest and know what you want to get out, and put all of that extra into training that person and everything like that, and giving them a certain set of tools and things like that to go and fix that aeroplane. If someone's going to fit a floorboard, you give them a bunch of nails, a hammer and a saw, right? I'm not a floor fitter, right? But that's the sort of context you have to start getting into. Now, if you go down this route, you have options. You can, for a microcomputer, you can do things like having hard drives. This is a hat which just literally plugs on, and you can put 2 extra hard drives on there, solid state hard drives. Then you come, so that's really the major difference. That will give you raw information, it'll give you control, it'll do something. That's brilliant. You want to go down the route of software, intelligence and control, then you want the Raspberry Pi. Now this brings us to the next point, which is I would definitely decide now which side of that has floated your boat. If you think of software engineers, they go for the Raspberry Pi. The hardware engineers will go Arduino. So you want to learn electronics, Arduino. You can learn electronics on a Raspberry Pi, and it's a perfectly good platform to learn electronics. But it's about knowing what you want to do with your life, because this is an all-consuming topic. It's fantastic. But this brings us to the next point, where you have to decide what floats your boat more, because the other one's a bit more of a drag. For me, I'm not a software guy. I'm a hardware guy. So I love the Arduino, love it, but I can't get away from the Raspberry Pi either, because the two actually work beautifully together. What you have is you break it down and you put the Arduino over on the conveyor belt, for instance. That will run the conveyor belt. The Raspberry Pi, on the other hand, is your interface into the system. It's the system manager, if you like. If you can use the two like this, then you are set up for success, because as the Raspberry Pi gives you everything, you can get all your visual, you can get computer vision with it. Oh, that's a beautiful topic with the Raspberry Pi. You can do defect monitoring and everything like that of products coming off your conveyor belt. But to control the conveyor belt, if you are monitoring products and things like that, you can't exercise the same level of control second by second or microsecond by microsecond in computer terms. That means that you need to split down the workforce. And I do say workforce because they are. You have your workers, which are the Arduinos, and then you have the managers, which are the Raspberry Pis. Now if you want to split down your workload like that, you can add another Arduino which can help with computer vision, or you can use a smaller Raspberry Pi like a Pico or something like that, which is going to help with computer vision and stuff like that. Although I'm not quite sure the Pico is quite capable for computer vision. More of a wireless sort of kind of card, which does complicated wireless and network authentication, stuff like that. Which brings on to the next thing, is networking. Now, the UNO R3 is not great for wireless. The UNO R4 Wi-Fi card is. It's a lot faster. The R4 is faster. If you're just getting into Arduino, I'd go for an R4. Just because it opens up all of the boundaries that we used to have with the R3. And I'm not going to go into that now because this is already getting a long video. I only wanted this 2 minutes and kind of gone over. I get excited about this. I can't help it. I love this topic. I love this subject. It's my life. It's my life. Engineering is my life. So let's say for instance, right, as an example, before I close out this video, you want to build a flight simulator, for instance. You would have these on microcontrollers, Arduino inputs, things like that. It will be listening for a click of that, and then it will send an output. And then in the code, it will send... It's probably broken now. It will send a coded message to the Raspberry Pi, which will then communicate as a one-stop shop to the main computer on the flight sim. So you might be running Windows 11 on your main computer, and you'll have that running Linux. You'll have the Arduino on Arduino code, and they all work seamlessly together, all looking for each other. So you could do something crazy like that. There are basics that we have to get under the way as well, like soldering, things like that. But anyway, this is getting a long video now, and I just wanted to welcome you to the channel. Comment down below if this is going to interest you. There's no point me spending hours and hours and hours creating content if no one's going to watch it. So please, let me know what you want to watch. Let me know how you want me to steer this series. What you want to create. What are your problems that you're having. Let's start a conversation, guys. Okay? Sorry it went on a little bit. I hope you follow along, subscribe, share, all that good stuff. And leave me a comment. Tell me what you're thinking. Okay? Alright, thank you.